क्लास कितने बजे तक होगी सर?
Whether the screen is visible to everyone?
Yes sir.
Yes, sir.
Okay. Only 38 people are present. Okay, let's check. So in the last class, what we have studied? So that is simple numerical problems on the simple beams. Okay. So in this class, we will. I had given a problem homework. No.
Yes,
Have you
sir.
solved?
Sir. Yes, sir.
Yes.
Yes,
Have you got,
sir.
have you got the answers?
Yes, sir.
Yes.
Yes,
Yesterday I received some of the answers. Okay, some people who have solved the problems, they have sent the questions. Okay, answers also. Okay, some have solved correctly and someone has made some small mistakes and all while calculating the moment. And okay, we'll check it. Okay, so now there are only 38 students. Okay.
सर आंसर्स बताइए ना क्या थे?
आंसर चाहिए क्या? आपका आंसर दे बोलिए पहले.
Yes,
बिकॉज वो रैंडम क्वेश्चंस था ना, सो मुझे आंसर्स पता नहीं. सो आपको आंसर्स बताइए, मैंने लिखते इधर. सो वी विल वेरीफाई विद अदर्स आल्सो. ओके, आपको आंसर्स बोलिए.
HA is equal to 0.
फर्स्ट इन द फर्स्ट प्रॉब्लम HA इज इक्वल टू
0.
0. ओके,
VA is equal to 58.75.
75 किलो न्यूटन. ओके, नेक्स्ट.
VB is equal to
61.25.
BB इज इक्वल टू
61.25.
यस, कितना?
61.25.
25 kilo. Is this answers are correct, all of you?
Yes, sir.
Okay, good. Second one. HA is equal to
0.
0.
0. Next.
VA
VA
is equal to 141.5.
Okay, good.
Maybe
Next.
B is equal to 103.5.
103.5.
5. Okay. Is this answers are correct, all of
Yes.
you? Okay.
Yes, sir.
yes,
Okay.
yes, sir.
Boys, are you getting same answers?
Yes, sir.
sir.
और boys का अलग आंसर से girls का अलग आंसर आ रहा है क्या? हाँ? No, no? All of you
नहीं
are
सर,
getting
सेम है.
Okay.
हाँ सर.
So yesterday I got one answer, that is he has calculated moment about A. Okay. So there is some corrections in the moment about A. Okay. So people are facing problem in finding the moment. Okay. We will verify that one. So before that one, I want to take some problems, that is some of the important theory part. I will take it. Okay. Yes, I will ask one by one. Roll number 25, Prajakta. Yes, turn on your mic.
Yes, sir.
What are the different types of supports?
Support.
Simple
supports, roller supports, fixed or hinged support, and built-in supports.
Fixed or hinged? nahi. Hinged or pinned. Hinged or pinned. Fixed or built-in. Okay. Next. Roll number I will call. 34. Rahul. Tell me, how many reactions will develop for the fixed the simple support? How many support reactions will develop for the simple support? Yes, roll number Rahul. 34 or 35? Wait, I will ask. Roll number 34, Mangesh. Tell me. How many support reactions will develop? Yes, I'm not able to hear you. Question. How many support reactions will develop for a simple support? Simple support ko how many support reactions will develop?
3, sir.
3. Okay. 3. This is 3. Okay. Next, tell me, for the roller support, how many reactions? How many support reactions?
सर
एक मिनट रुको, लेट हिम आंसर. उन्होंने आंसर कर रहे हैं. हाँ बोलिए. नेक्स्ट, रोलर को कितना? मंगेश, टेल मी. रोल नंबर 34, मंगेश. रोलर सपोर्ट का कितना सपोर्ट रिएक्शन है? See, whenever I ask any questions, you have to answer, no? Vikram, roll number 30, Vikram. Yes, please turn on your audio. Unmute yourself. Roll number 32, Vivek.
Yes, sir.
Tell me, how many support reactions will there for simple support?
One reaction, sir.
Only one reaction. What is that one? Horizontal,
Normal.
vertical movement.
Normal to the plane.
Normal, that is vertical. Okay, vertical. Vertical reaction. Good. Next, roller support.
Perpendicular to the plane.
Okay, it means how many reactions?
Only one reaction.
Only one. What is that? Vertical reaction.
Hmm.
Okay. Next, hinged or pinned support. How many?
One vertical.
For the hinged, one.
Vertical and one horizontal.
Total how many?
Two
So
reactions.
two. Okay, two reactions. One is horizontal and one more is vertical. Next, for the fixed or built-in support, how many?
Three reactions.
Three reactions. One is
Vertical, horizontal, and
vertical,
residue.
and
Residue.
movement.
Movement.
Okay.
Movement.
Okay. So these are the three equations. Okay, reactions you are getting fixed. So you are not supposed to forget. You have to remember all these reactions. Okay. Next, after this point, we have studied the simple support. Okay. So from this diagram.
सिंपल सपोर्ट में मतलब कोई भी एग्जांपल आ सकता है ना, अगर हम हमारी पेंसिल भी रख दे तो भी वो उसमें आएगा ना.
Yes. Okay. So if you consider this is a slab, okay, I am placing my beam pen on the slab. Okay, that will become a simple support. Okay, wait a minute. Okay. So this is a slab. So I am placing like this. Okay, that is nothing simple support. If you consider like this also. If you consider this is one table, okay, over that one, if you are placing another one material like this, so this will become simple support. Just you have to place it, that's all. Okay, you are not supposed to give any load or anything, just you have to place. So see, there is a wall, here is a wall, here there is a wall. Over that wall, if you are placing any slab or any material, that will become simple support. So if you take one table, okay, chair, over the chair, if you are sitting, okay, okay, that will become simple support. Okay, anything you have to just simply resting on that one material to another one. Okay, so this is important. Roller support, that is vertical reaction. So pinned, that is vertical and horizontal. So fixed, horizontal movement, and one more is vertical. So simple support, that is only one. Okay, so this is important. Next. Okay, so roller is only one, pin is two, simple is one, fixed is three. See, there is a figure. Okay, in this figure, so there is a one slab. Okay, in this slab, there is a slab is resting on the wall. Okay, see, the slab is resting on the wall. So if you consider this is a slab, just a slab is resting on the column or wall. There is reaction, that is only vertical, that is simple support. So when you coming to the roller support, so roller means there is a rollers are provided here. Okay, rollers. So for the rollers, there is a vertical reaction. See, if the rollers are like this, inclined, okay, inclined, so our reactions are always normal to the plane. So this is normal reaction. That is also making an angle theta. Okay, so this is the roller. Okay, so reactions will develop like this. Reactions will develop like this. So if you consider this is a hinge, okay, this is a hinge. Is it visible now? Whatever I am writing.
Yes.
Yes,
Okay. So this is hinge. Okay, for this hinge, again there is a two. One is vertical and one more is horizontal. This is hinged or pinned. So there is a fixed support. So for this fixed support, how many reactions will develop? This is a, see, one member which is fixed in the wall. Okay, so that is fixed. For this member, so there is moment about a point, horizontal reaction, vertical reaction. Okay, These are the different conditions of the support reactions. Is it clear,
Sir,
everyone?
वो हिंज्ड सपोर्ट्स में सर टाइम का कुछ रिएक्शन होगा क्या उस पे?
टाइम का?
हाँ सर।
टाइम का क्या है?
टाइम नहीं है ना।
ओके सर, ओके।
फोर्स ही सर मतलब इसमें आएंगे ना?
क्या?
टाइम फोर्स ही मतलब आएंगे ना?
No, time की जरूरत नहीं. Just hinge means what? So there are only two types of reactions. See, this is your door का frame है. Okay, total door का frame. So there is door का एक पैनल है. Okay, so door का एक पैनल फिक्स करने का है. See, door का एक पैनल फिक्स करने का. Okay, so this is the door का एक पैनल फिक्स करने का है. So initially, just a minute. I am taking one box. Okay, so this is door. Okay, door का frame है. This is door का frame. So over this door there is a door panels. I need to fix it. So how to fix that door panel? Okay, so this is one door panel and this is another door panel. Another door panel. So I have to fix that door panel to the frame. So how to fix this frame? So there is a hinges. There is hinges. Are you getting all of them? So there is
Yes, sir.
hinges.
Yes.
So there is hinges. Okay. So what these hinges will do? Is it moving in a horizontal direction? Door का frame horizontal direction move होता है क्या?
नहीं सर।
नहीं. It means it is not providing any horizontal. It means there is a reaction in the horizontal direction. Is it moving in the vertical direction? This hinges or this door frame. Okay. Is it moving in the vertical direction?
No.
नहीं
No.
सर।
It means there is a vertical reaction. Is it rotating? Rotating?
Yes, sir.
Yes, there is a rotation. If it is a rotation, so means the rotation is allowed. The rotation is allowed means what? Is it there moment? Moment is there any moment? Moment
Yes.
is
Yes.
zero. There is a horizontal reaction. There is a vertical reaction, but moment about that point is zero. Are you getting?
Yes sir।
इसमें horizontal reaction नहीं रहता, vertical भी नहीं रहता. Means it will not move in vertical reaction. It will not move in horizontal direction. Okay, but it will rotate. Rotation is nothing but what? That is your moment. Okay. So when there is a rotation, it means moment is zero. Hinges में hinge में क्या रहता है? Moment is zero.
मूवमेंट कैसे जीरो है
हाँ?
सर? मूवमेंट कैसे जीरो है और रिपीट से बताएंगे क्या थोड़ा?
Yes. What is moment? Can you tell me? Moment मतलब क्या है?
Force into perpendicular distance.
Force into perpendicular distance. Force into perpendicular distance. Okay. So whenever, what is the moment actually? Couple means what? It is the rotational effect. Correct. Moment means what? It is the rotational effect. Rotational effect. Rotation. Whenever there is a rotation is there, then there is a always moment is equal to zero. Okay. See, in this one, where you are applying the force, okay, the rotation is moving at this point. Rotation is moving at this point means the force is acting at this point, but perpendicular distance nahi na. Is there any perpendicular distance? No. The net moment is equal to zero here. It means the rotation is allowed, okay, but there is no distance. Okay, so whenever you go, okay, yeah, this is the hinges. In the hinges, rotation is allowed. Rotation is allowed means there is no moment. Okay, see, just come to the point. Which one? Roller point. Roller means what? There is a rotation is allowed. Okay, and is it moving in the x direction? Is it moving in the y direction? No. Yes, it is horizontal is possible.
Horizontal. Yes,
Horizontal is
Not
possible.
vertical.
Okay, and it can rotate. But is it moving in a vertical direction? No, it will not move in a
No,
vertical. That's why there is a vertical reaction is exist. Okay, so what is exist? In that direction, it is not possible. Okay, see, in the simply supported, there is a vertical reaction. It means it will not move in vertical direction. In the roller, there is a vertical reaction is exist. It means it will not move in vertical direction.
सर मतलब जहाँ पर मतलब जिस डायरेक्शन में वो जाता है वहाँ पे रिएक्ट नहीं करता और जहाँ नहीं जाता वहाँ पे करता।
Yes, that is the point. अभी देखो hinges में क्या है? Is it moving in the horizontal direction? Is it
नहीं
moving?
सर।
Is it moving in the vertical direction? It is not
नहीं,
moving.
sir.
It means there is a reaction. किधर reaction रहते? There is no possibility. But it is rotating. It is rotating means moment is equal to zero. अभी देखो इधर फिक्स में आ जाओ. So there is a one material. Okay, एक बार है. I will fix that bar into wall. Okay, इसे फिक्स करने के बाद इसके ऊपर फोर्स डाल दो. Is it moving in the x direction? Is it moving in the x direction?
No, sir.
No, it is not moving. It means there is a resistance against the x direction. When there is a resistance in the against the x direction, that means horizontal reaction will develop. Next, is it moving in the vertical direction?
नहीं सर.
No, it means
No,
there is a
sir.
resistance against the vertical. Means there is a resistance in the vertical reaction. Just vertical reaction will develop. Is it rotating? Is it rotating? It
नहीं
is not
सर.
No,
rotating.
sir.
It means it is
No,
not
sir.
rotating means there is a resistance against the rotation. Resistance against the rotation means there is a
Movement
moment is
आएगा.
exist. Moment is exist. Is it clear, everyone?
Yes sir.
Okay.
Yes, sir.
Sir,
Ah.
sir,
So till now you have seen what are different types of supports and what are different types of loads. So now we will come to the point. What are beam? Can you tell me what is beam? What is beam? Okay. Now tell me what is one-dimensional element? What is one-dimensional element? 1D element.
सर वो फोटो सर जो आपके वो स्क्रीन पे.
हाँ. Clear नहीं ना? Clear नहीं?
नहीं क्लियर है.
हाँ. Okay. These are the one-dimensional element. Huh?
हाँ वो कहा.
Okay, good. I want definition. Right? One dimensional element means the element which is having only one length. Okay, it means we have x direction, we have y direction, we have z direction. Okay, we can measure any one type of material. Just a minute. Okay. Okay. So it means we can measure in only one direction. That is nothing but length. Okay. The other two dimensions are not considerable. Okay. Means the one direction is very long as compared to the other two directions. That is that nothing but one dimension. Two dimensional. Two dimension is the any two dimensions are measurable, but the direction is very small. In when you consider the slab में thickness it is only in mm thickness, but the length and width it is in meter. Length and width are in meter. When you coming to the 3D, okay, when you are coming to the box, okay, you can consider any box. So consider there is a box, there will be any box. So for this box, there will be length, there is a width, there is a depth. Okay, it means you have to consider length, width, and depth. Okay, for the foundation, you have to consider all the things. Okay, that is 3D element. So when you are coming to the beam is defined as it is a structural member which is used to bear the different types of loads. Beam is a horizontal structural member which is used to bear a different types of loads. You have seen what are the different types of loads. What are the different types of loads?
point load.
Point load,
fixed load.
UDL or
DL.
UVL.
UVL or general loading भी.
Okay, so the beam is a structural member which can resist horizontal or vertical or different types of loads. It resists vertical loads, shear force, and bending moment. In the regards to the beam, if the this point I explained in the last class, if the reaction forces can be calculated using the equilibrium equations alone is very important. Alone, then they are called as statically determinate beams. Statically determinate beams. What is statically determinate beams? If the unknown reactions or the support reactions can be determined by taking the help of equilibrium equations only. then that is called as determinate beam. That is called as determinate beams. See, this sentence is very important. So if the reaction forces or the support reactions can be calculated using equilibrium conditions alone, then that such a beam is called as statically determinate beam. Okay, so if at all, on the other hand, if the reaction forces cannot be determined using the equilibrium conditions only, then the other method have to be used and structure is said to be statically indeterminate beam. Okay, statically indeterminate means what? If the support reactions are not able to find out with the help of equilibrium equations only, then such a beams are called as indeterminate beams. Okay, this point is important. Okay, what is this one? Support reactions cannot be determined using the equilibrium equations only. Such a beams are called as indeterminate beams. Is it clear, everyone?
सर मतलब सिर्फ लैमी का थ्योरम ऐड किया तो, या कौन सा भी थ्योरम जो हमें आप पढ़ाओगे?
Lami's theorem?
हाँ
No.
मतलब यहाँ पे वो सेकंड पॉइंट में आपने कहा ना सिर्फ इक्विलिब्रियम इक्वेशंस नहीं, उसके अलावा कोई भी, मतलब लैमी का ही चलेगा, कोई भी चलेगा?
No. What are the equilibrium equations? Can you tell me?
वो एक Fy और Fx वाले सिग्मा.
Yes, sigma fx, sigma fy, sigma m is equal to 0.
M वाला.
See, how many conditions are there? Sigma fx एक condition है, sigma fy एक condition है, और sigma moment about एक है. ये तीन conditions है. See, we cannot find out the support reactions, means there are three conditions. It means these statically indeterminate structures are having more than three support reactions. More than three support reactions. If these are more than three support reactions, can you find out with the help of only three support conditions? आपके हमारे पास इक्वेशंस कितना है, हमारे पास कंडीशंस कितना है? Only three है, but unknowns कितना है? It is more than three unknowns है. You cannot find out, no. So such a beams are called as
indeterminate.
Okay, but for your syllabus in the exam or for your syllabus, there is only statically determinate structures. Okay, whichever type of beam he will give, that beam should be that is statically determinate beam, and you can apply only equilibrium conditions. Okay, so where you can find this indeterminate structure, that you will study in the when you are coming for the higher studies. Okay, that is in the second year and third year of civil engineering and mechanical engineering. There you will study the statically indeterminate structures. Clear, everyone?
Yes, sir.
Yes, sir.
Okay. So now you will study only determinate structure. All of you write on this part. All of you write down. Beams. A beam is defined as the structural member which is used to bear different loads. Full stop. Next, write this part. Okay, I will dictate like that. You have to write. If the reactions or isolate, if the support reactions of a beam can be calculated using equilibrium equations, if the support reactions of the beam can be calculated using equilibrium equations alone, comma, then such a beams are called as such beams are called as statically determinate beams. Statically determinate beams. Statically determinate beams. Are you getting? If the support reactions of a beam can be calculated using the equilibrium equations alone, then such a beams are called as statically determinate beams. Next point. If the support reactions of a beam cannot be determined using equilibrium equations only, then such a beams are called as called statically indeterminate beams. Statically indeterminate beams. Is it clear, everyone?
Yes, sir.
Okay, so it is very, very important for one mark questions, multiple choice questions. So determinate beams. Okay, options 1. We can find out with the help of equilibrium condition. Option 2, we cannot find out with the help of equilibrium conditions. Option C, both. Option D, none. What is the answer? For determinate structure, we can find out with the help of equilibrium conditions. For indeterminate structures or indeterminate beams, we cannot find out with the help of support reaction, equilibrium condition. Okay, sir, then what are the different types of beams? Okay, so types of beams. So these are the different types of beams. So first one is cantilever beam, simply supported beam, overhanging beam, fixed beam, continuous beam. Okay, so I'll read on this flow chart. Types of beams. Types of beams. First one, cantilever beam. Second one, simply supported beam. Third one, overhanging beam. Fourth one, fixed beam. Fifth one, continuous beam. Is it clear?
No, sir.
First one is
Yes, sir.
cantilever beam. Second one is simply supported beam. Third one, overhanging beam. Fourth one, fixed beam. Fifth one, continuous beam. Okay, you should remember these points. Okay, if anybody asks you what are the different types of beams, so okay, you should tell. Okay, is it over?
Yes, sir.
सर इसमें से 3 तो आप भी हुए ना सर,
Yes.
वो सिंपली ओवरहैंगिंग और वो फिक्स्ड वाला आपने शायद कल एग्जांपल लिया था ना ओवरहैंगिंग वाला.
Yes. I will explain. So what is cantilever? What is simply supported? Okay, I will tell. Okay. So first one. So what is first one? Cantilever beam. So first of all, you should know beam. Beam means what? It is a horizontal member. Okay, it means one dimension is very, very large as compared to the other two dimensions. In the beam, the length is very large as considered to its width and thickness. Okay, so this is cantilever beam. So in the cantilever beam, AB is a cantilever beam. The one end of the support is fixed. One end of the support is fixed. A cantilever beam is a beam that is fixed from one end and free at the other end. So at the B, is it fixed or it is free?
Free.
It is free. At A, it is fixed. Okay, it is fixed end. It is free end. Free end. Okay. So what is cantilever beam? So a beam which is fixed at one end and free at the other end. Next, in the figure, you can see that one end, that is A, is fixed and the other end, that is B, is free. So this beam is called as cantilever beam. Is it clear, everyone? What is cantilever beam? One
Yes,
end
sir.
is fixed, other end is
Yes, sir.
free. Okay. All of you read on this one. First one is cantilever beam. Cantilever beam. So draw this diagram. You can also draw like this also. Okay. This is the cantilever diagram. This is A, this is B. Okay. So when you remove this support, okay, which type of support it is?
Fixed.
Fixed. Okay. For the fixed support, how many reactions will develop?
3.
3.
So it will having 3 reactions. If it is having 3 reactions, then how many equilibrium equations are having? We are having
3.
3.
3.
There are 3 equilibrium equations. Okay, 3 equations. There are 3 reactions. Okay, reactions. Is it determinate structure or indeterminate?
Indeterminate, sir. नहीं सर, एक मिनट सर.
Determinate.
Yes, it is a determinate. It is determinate. So cantilever determinate. Okay, cantilever beam is determinate structure or determinate beam because there are three equations. There are 3 equilibrium equations. Okay, 3 equilibrium equations, and there are 3 reactions. 3 reactions. We can find out though. We can find out there is RA. Okay, there is HA. Okay, there is vertical VA. Okay, there is moment MA. Okay, we can find out these HA. We can find out VA. We can find out MA. We can find out. It means we can find out the support reactions with the help of equilibrium conditions. So that this is determinate structure beam. Determinate beam. All of you, are you agreeing?
Yes, sir.
Yes, sir.
This is
Yes, sir.
Yes, sir.
cantilever beam is it is determinate beam. Have you drawn this diagram?
Yes, sir.
Okay. So in the figure, one end that is A is fixed and the other end B is free. So this beam is called as cantilever beam. Okay, it is determinate beam. Shall I go for next second type of beam, simply supported beam? Is it over?
Yes, sir.
Yes, sir.
Okay. So what is second one?
Simple support.
Simply supported beam. See, simply supported beam. So here a beam which is supported or resting on supports at its both the ends is called as simply supported beam. So what are the supports? Ends. A is one end, B is one end. These two ends are just they are resting on the support. A beam which is supported or resting on the supports at its both ends. Okay, A and B are resting on the supports. Then it is called a simply supported beam. Okay, this is simply supported beam. Okay, they are resting. So at a simply supported beam, how many reactions are there? At A, how many reactions? 1.
1.
At B, how many reactions?
1.
Total
1.
1 plus 1 is equal to Two
Two.
reactions. How many equilibrium equations are there? Equations are how
Two.
many equations?
2.
That is sigma fx, sigma fy, sigma fy, and that is momentum. Okay, there are three equations. There are two unknowns. Is it possible to find out the reactions with the help of equilibrium equations or no?
No, sir.
No.
No, sir.
Huh? No.
सर
Yes, sir.
कर सकते हैं ना क्योंकि
Yes,
हमारे पास
there is a
इक्वेशंस तीन है
reactions
हाँ
R1 and R2 reactions. Okay, R1 and R2. Okay, there are two unknown reactions. We have equilibrium equations are three. We can find out. No, we can find out sigma fx and sigma fy and moment about A. It means simply supported beam is a. It is determinate beam. It is also determinate beam. Okay, because there is one reaction, there is one reaction, two reactions and three equations we can determine. See, in the above figure, both ends of the beam is supported by supports. One support at A and the other support at end B. The beam is known as simply supported beam. Is it clear?
yes
Okay,
sir
write down. Second one is simply supported beam.
सर वो फिगर भी निकाले ना
हाँ फिगर निकालो. ओके ऐसे भी लिख सकते और आपको चाहिए तो जस्ट यू कैन ड्रॉ ए लाइन. ओके सो लाइन ड्रॉ करने का यू हैव टू प्रोवाइड सपोर्ट्स. ओके सो दिस इज द स्कीमेटिक सपोर्ट लाइक दिस. ऐसे कर सकते. इट मींस देयर शुड बी ओनली वन रिएक्शन एट ईच सपोर्ट. Is it over?
Yes, sir.
नो सर एक सेकंड
No, sir.
Okay. So next one. What is next one?
Overhang.
Overhanging beam. It means in this beam, if one end of it is extended beyond the support, it is known as overhanging beam. Okay. So as shown in the figure, we observe that beam is extending beyond the support beam, and hence this beam is called as overhanging beam. Okay. So initially from A to B. Okay, only if it is A to B, then it is called a simply supported beam. If the portion of the beam is extending away from the support, then that support is called as that portion is called overhanging portion. So this is overhanging portion. Okay, portion, or it is entire beam is called as overhanging beam. Okay. How many reactions are developed at this support? It is simply supported, correct? This is
yes,
one. So this is
One.
also
One.
one simply
One.
supported. This is also one. Total how many reactions?
Two.
Two. How many equilibrium equations?
थ्री
Three. Is it determinate or
Three.
indeterminate?
Determinate.
Determinate. Okay. Determinate. So all of it are done this one. Okay. So just take the screenshot. Okay. Afterwards you can write it. Just take the screenshot. I will complete first this one. Okay. Have you taken?
Yes, sir.
Okay.
Yes, sir.
So you have to write it afterwards. So fixed beam. So what is fixed beam? So in the fixed beam, a beam which has both of its ends is fixed, or it is built-in walls is called as fixed. Okay, there is a AB is a beam. A is one support. It is fixed, and B is another end. It is also fixed. Okay, it means such a beam is called as fixed beam. Then A is fixed. How many reactions will develop at A?
3.
3. B is fixed.
Three.
How many
3.
reactions will develop? 3.
Three.
Total how many reactions are there?
6.
6. How many equilibrium equations are there?
Undetermined.
3.
3. Is it determinate or indeterminate?
Indeterminate.
It is
Indeterminate.
indeterminate beam. Okay, indeterminate beam. So always fixed beam is a indeterminate beam.
सर
Ah,
फिक्स बीम बोला तो मतलब दोनों तरफ सॉरी दोनों तरफ से भी वो उन्होंने फिक्स किया होगा, एक तरफ से नहीं किया होगा।
no, both are fixed. If it
एक
is
तरफ से
only
किया तो वो उसमें जाएगा।
that
हाँ।
will, if it is only one type, one end is fixed, then that is called as cantilever. That is called as cantilever. If both the ends are fixed, then that is called as it is fixed beam. Okay, fixed beam. Are you getting differences?
Yes sir.
Okay.
Yes,
In the
sir.
figure, both ends of the beams are rigidly fixed in walls. This type of beams are known as fixed beams. Okay. Are you getting all of you? If both the support ends are
Yes,
fixed,
yes,
then
sir.
that is called as fixed beam. If only one end is
Yes, sir.
fixed, then that is called as cantilever beam. So take this screenshot. Okay. Okay. So next one is continuous beam. So in this continuous beam, okay, it is a beam which is provided with more than two supports. More than two supports. See here, there is a support. Which type of support it is? Which type of support?
Simple.
That is simply supported. Here also simply supported. Here also support. There are three support. But in the beam definition, a beam which is provided more than two supports. More than two supports. Okay, it is 3 support or 4 support or 5 support. So it is called as continuous beam. So here we can see in the figure, the beam has more than two supports A, B, and C. The beam is called as continuous beam. Okay, so in this case, only 3 supports are there. We have 3 equilibrium equations. Is it continuous, determinate or indeterminate?
Determinate.
Now it is
Sir,
determinate.
मतलब अगर क्वेश्चन में उन्होंने 3 से ज्यादा दिया होगा तो वो
Yes.
इंडिटरमिनेट हो जाएगा।
Wait. I am explaining that also. Okay, wait करो. So
Okay,
in this
sir.
problem, मैंने वही specify कर रहा है. In this problem, there are only 3 reactions. That's why you are telling it is determinate. In suppose, instead of A support is simply supported, if he has taken hinged support, how many reactions will develop at this point? Yes,
Two.
how many?
Two
This is one, this is horizontal one. Now tell me, how many reactions are developed at this is one, this is 2, at B, this is 3, this is 4. How many reactions are there? 4. How many equilibrium equations are there?
3.
3. Is it determinate or indeterminate?
Indeterminate.
So always continuous beam is taken it as indeterminate, because he has specified more than 2. It may not, he is not specifying only 3. Okay, it may be 3 or 4 or 5 or 10 or 20. So it is a indeterminate beam. Is it clear, everyone?
Yes sir.
Yes, sir.
सर वो आखिर का कुछ मैटर नहीं क्या करेगा वो ओवरहैंगिंग वाला?
No, this is not a matter. Okay, so there may be another support also. So who knows?
Okay sir.
Another support that is 4 reactions. Okay, that will become 4 reactions. So if there is more than 2 reactions are there, then it is continuous beam. Okay, if there is only 2 reactions with overhanging, then it is called as overhanging beam. Overhanging beam. Is it clear? Only
Yes sir.
2 portion रहने का, 2 portion रही तो that is overhanging. If there is more than 2 portion, then that will become continuous beam. Okay, take down this figure. Take this screenshot. Okay. Okay. See in this figure. Okay. So all 5 beams are I have taken in one single slide. Okay. So आपको याद रखने के लिए. So see beam. This beam, one end is fixed. Is it correct? Which is that means that is cantilever beam.
Yes, sir.
So in this case, simply supported. So what here? There is a roller. Okay, roller of only one reaction. You can take it. Okay, only one reaction. So it is simply supported. So here, see, this is one portion. This is one portion. Is it simply here? It is simply supported. Only this portion. There is the extended portion is there, no? So that's why it is called as overhanging.
Overhanging.
So in this here, at end A, at end B, both are fixed. Both are fixed. It means which type of beam it is?
Fixed.
It is fixed beam.
Fixed
So
beam.
here, see, there is a hinge. There are two reactions. There is hinge, two reactions. There is two. How many reactions? 6. How many it is?
6.
It is continuous beam. Continuous beam. Is it clear, everyone?
Yes, sir.
Okay.
Yes, sir.
This one we have seen. Okay, so this is point load, this is UDL, this is UVL. Yes, here one more point I need to explain. In the UVL, there are two types of loads. Okay, so one is triangular loading, and another one is trapezoidal loading. Triangular loading and trapezoidal loading. So in the triangular loading, so the one side is 0 and another side is maximum. In the trapezoidal loading, so one side is minimum, another side is maximum. What I am saying, understand, try to understand.
Yes,
what I am
sir.
saying. So in the triangular loading, one side is 0 and the other side is maximum. See here, so here it is 0, here it is 0 and here it is maximum. So here it is maximum. In the trapezoidal loading, here it is minimum. I'm specifying minimum. I'm not specifying 0.
0.
Here it is minimum. Here it is maximum. Okay. So here it is max. Okay, like this. Is it uniformly distributed or it is varying?
Varying.
Both
Varying,
are,
sir.
so both are example for the varying. Okay. So uniformly varying, that is triangular loading and trapezoidal loading. Both are uniformly varying. So in the last class, I have told how to convert this triangular load into equivalent point load. Can you tell me how to convert that into equivalent point load? Half.
One half intensity.
Base is how much?
Intensity.
That is length of the span into height. Height is how much it is? It is intensity of load. Intensity of load. Correct. So where this exact all load is acting? Where that all entire load is
Centroid.
acting? At the centroid. At the centroid. So this centroid is at a distance of, tell me. So if you take this total
1/3 or
L,
2/3.
that is 1/3 of L. That is from the highest loading.
Hill.
Highest loading say 1/3. From the lowest loading say
2/3.
2/3.
2/3. Okay. If it is trapezoidal loading, then what to do? How to find out? So you have to divide this load into two part. So this one part, it is UDL, correct?
Yes.
Okay. This another
Yes,
part,
sir.
it is triangular load.
UVL.
UVL, triangular load. So whenever there is a trapezoidal load is given in the problem, you have to convert two equivalent concentrated load. One for UDL and another for UVL. Okay, where this UDL is acting? That is acting at the center of the UDL length. And where this triangular load is acting? At the
Centroid.
1/3 or centroid or
Centroid.
1/3 from the highest loading. Is it clear, everyone?
Yes, sir.
Okay.
Yes,
So
sir.
if you know this much, we can solve any kind of problems. Okay. So we have solved all these problems. Okay. So I will take one problem. We'll see. All of it take down. Determine support reaction. Determine support reaction for the beam shown in the figure. For the beam shown in the figure. For the beam shown in the figure. So all of you draw this figure. Which type of beam it is?
Cantilever.
It is cantilever beam. Okay.
सर उन सब के हाइट से में हम इसे यूनिफॉर्मली डिस्ट्रीब्यूटेड कह सकते हैं क्या?
This is same, है ना? So UDL is denoted like this.
यस सर.
Oh, UDL is denoted like this. Okay, so this is the bigger figure which is given in the problem. Have you taken?
Yes, sir.
First, how to solve this kind of problems? Okay, so whenever beam is given, you have to draw its free body diagram. Okay, free body diagram means you have to remove the support and you have to give the support reactions. Okay, I will draw the same figure. So this is the big given beam. Okay, so in this beam there is a concentrated load at the beam. Yeah, I will draw concentrated load beam. Okay, there is a 20 kilonewton which is acting at an 60 degree. That is also okay. If you want to write this point load, equivalent load, you can write, or you can write UDL. You can write. Okay. Next, so at the C point, at the A point, is it which type of support it is?
Cantilever.
Cantilever. Okay, it is which type of support? Support.
Fixed support.
Fixed. So how many reactions will develop at the fixed
Three.
support? Three.
Three.
Okay, what are those?
Vertical
Horizontal and moment.
movement.
This is horizontal. This is vertical, and there is one moment. Okay, I will take it as moment. Okay, in this direction. Okay, any direction you can take. Okay, so you can take clockwise or you can take anti-clockwise. Finally, if you are getting answer positive, assume direction is correct. If you are getting answer negative, then assume direction is wrong. Okay. So this is, I will take it as MA. This is VA. This is HA. Is it clear, everyone? Okay. So whether I need to convert this UDL into a concentrated load or we'll keep it as it is. दोनों भी कर सकते हैं, ऐसे ही रख के भी कर सकते हैं, और if you want to convert, you can convert that also. So क्या करेंगे? बोलिए आप कैसे बोलते हैं वैसे करेंगे.
Convert करिए.
Convert करने का, okay, ठीक है. So 15 kilonewton and it is 60 kilonewton, which is making an angle 60 degree. Okay. So I will convert this load. So equivalent point load, equivalent point load, that is equal to convert. So that is length, the intensity of UDL, into length of UDL. Okay, so that is equal to, what is the intensity of UDL?
10
kilonewton per meter into, what is the length of the UDL? 2 meter. Okay, that is equal to 20 kilonewton. Okay, where this 20 kilonewton is acting? It is acting at the center of the length of center of the UDL. Okay, so now can you tell me what is the distance?
1 meter.
Yes, it is 1 meter. Okay, from this point to this point, it is 1 meter. Then from this point to this point, it is 1 meter. Then remaining, it is 1 meter.
1.
Okay. So you can change. That is 1 meter. So that is 1 meter. This is 1 meter. Okay, everyone, is it clear? So that is equal to 20 kilonewton. Next, so in the last problem, there was purely vertical loads. In this problem, there is an inclined load. So how to convert this inclined load into a resolving component? That is along x direction and along y direction. So I have to convert this into resolution, correct? Resolving of forces, first class chapter. Okay, how to convert that into? One is horizontal component, another is vertical component. Okay, so iska horizontal component I will let. So that is equal to, in which direction it is moving?
20 cos 60.
It is in which direction? Left hand direction. And its vertical component, that is moving in downward direction. Is it correct?
Yes.
Okay.
Yes.
So what is the x component force?
Yes, sir.
What is x
20
component?
Minus 20 cos 60.
20 cos
60.
60. Then vertical component?
20 sin.
Minus
20 sin 60.
20 sin 60. So how I will write? I will rewrite. Okay. So I will take this entire in the horizontal. So I will take like this. This is horizontal component. This is vertical component. Now I will not take inclined one. Okay. Directly I will take horizontal component, vertical component. So horizontal is 20 cos 60 and vertical is 20 sin 60. Is it clear? Okay, everyone?
Yes, sir.
Okay. So now it's applying equilibrium conditions. So I will write one point. That is
Minus I gonna 20 sin 60.
minus Q. So I have already taken its direction. Okay, already I have taken its direction itself shows that it is downward.
Okay,
Okay.
sir.
So next, so let all of you read on this one. Okay, I will write something. Let the reaction developed at fixed support B, VA, HA and VB. Sorry, VA, HA and ME. VA, HA and ME at fixed support. So consider equilibrium equations. Consider equilibrium equations. Okay. So concentrate. Okay. Afterwards, I will give time for the writing part. Okay. All of you concentrate at this point. Okay. Stop writing. Looking at the board. Okay. All of you look at the screen.
Yes.
Okay. So let us consider the reactions developed at the fixed end. Support B, VA, HA, and MA. Okay. Horizontal is HA, vertical is VA, and rotation moment is MA. Consider equilibrium equations. Okay. So what are the equilibrium equations? First equation, can you tell me?
Sigma fx
Sigma
is equal to
fx.
0.
Sigma fx is equal to 0. So here x is moving in the positive direction. It is positive. If x is moving in the negative direction, it is negative.
Minus.
Now tell me. So what are the forces? The forces which are moving in horizontal direction. Tell me.
2.
What are those?
HA.
HA is moving in the positive x direction or negative x direction?
Positive.
Positive. Is it
Positive.
It is plus HA. Okay. Next, is there any other force which is moving in the horizontal direction?
Yes.
What is that?
20 cos 60.
Yes,
20
cos
cos
60. Now you can mention
Negative.
positive or negative. It is
Negative.
negative. That is 20 cos 60 degree. Okay, that is equal to 0.
0.
Next, HA is equal to, what is the value of HA? 20. You transfer this 20 to other side.
20 cos 60.
20 cos 60, that is equal to 10 kilonewton.
Yes, sir.
Okay.
Yes, sir.
So this is 10 kilonewton. That is the your value of HA. So in the last class problem, HA was 0 everywhere, correct? But in
Yes,
this
sir.
problem, HA is 10 kilonewton.
Yes, sir.
Are you getting all of you?
Yes, sir.
Okay.
Yes, sir.
So next point is, so that is second equation. So what is your second equilibrium equations? Second one. Huh? So
Sigma Fy is equal to 0.
Fy is equal to 0. Fy, y is moving upward direction. Positive or negative? Positive. If y is moving downward direction, positive or negative?
Negative.
Negative. Okay, tell me, what are the forces which are moving in vertical direction? First, I will start from A point. That is VA. VA is moving upward direction.
Upwards.
Plus VA. Next, this 20 is moving downward direction.
Minus 20.
Minus 20. Then this
Minus
20
20
sin 60 minus downward 20
20
sin
sin 60.
60. Okay. So is it necessary to consider this 20 kilonewton?
No.
No,
I
sir.
am not supposed to consider because I have already resolved.
Yes, sir.
Then
You have
next
put
is
it.
15 kilonewton.
15 kilonewtons.
Minus 15 kilonewton. That is equal to 0. Okay. So next, VA is equal to. So this is, I will transfer that to the right hand side. That is 20 plus 20 sin 60 is equal to root 3 by 2. That plus 15. So calculate how much you will get VA. All of you?
17.6.
Yes, that is equal to how much?
17.6.
No.
52.32.
Yes, 52.32. 52.32. Is it correct? Yes, 52.32. All of you should get the same answer. Okay. So after finding the value of VA, then what is remaining? What is remaining? What is remaining? M about A. So which condition will you apply?
So, sigma is equal to
Yes,
0.
summation of M about which point equal to 0? Which point equal to 0? That is
A point.
about A point. About A point is equal to 0. Moment about A point is equal to 0. Okay. So applying. So H and V are passing through the point A. Is it producing any moment?
No.
No. But there is a moment about A. So this moment about A is moving, rotating clockwise or anti-clockwise?
Anti.
Anti-clockwise. Plus or minus?
Minus.
I'll
Minus.
take here. So this is anti-clockwise is minus and clockwise is positive. Okay. So minus MA. Okay. Next, this 20 kilonewton, is it producing positive or clockwise or anti-clockwise rotation?
Clockwise.
Clockwise. How much it is? Plus, tell me.
20.
20 into 1.
1.
Next. So here, 20 sin 60, it is vertical. It is producing clockwise rotation.
Clockwise.
So that is plus 20
Plus
cos 60.
sin 60.
Sorry, sin correct. So 20 sin 60. Sin 60. It is force into distance. Distance from A point A. So from point A to this point, how much it is? 2 meter.
2.
Next, there is a horizontal force 20 cos 60. Is it producing any moment?
No.
No. Why? Why it is not producing?
They
Passing
are
through
passing point A.
Yes, this 20 cos 60 is passing through the point A. There is no perpendicular distance. That's why it is not producing any moment. Is it understanding now, all of you?
Yes, sir.
Okay.
Yes, sir.
Next force is 15 kilonewton force. Okay. So this 15 kilonewton force will rotate in clockwise or anti-clockwise?
Clockwise.
Clockwise. That is plus. That is 15 into. How much is the distance
3
from
meter.
A to
3 meter.
3 meter.
3.
It is equal to 0. Now transfer this MA to the other side. That is equal to plus MA is equal to, so 20 into, so calculate all of it. 20 into 1, that is 20 plus 20 into sin 60, that is equal to root 3 by 2. So next plus 15 into 3, that is equal to 45. Okay. So calculate MA.
Yes, sir. 99.64.
Is it correct?
Yes, sir.
99.64. What is the unit? What is the unit for moment? Unit for moment is what? Kilonewton meter. Okay. So this is the answer for the all three conditions: HA, VA, and MA. Are you getting all of you?
Yes, sir.
So
Yes, sir.
this is somewhat different from the previous problem. Is it correct?
Sir,
हाँ.
मतलब हम ये कह सकते हैं कि अगर हमें एक एंगल उन्होंने अगर हमें इंक्लाइन दिया तो फिर हमें एच की वैल्यू मिलेगी, और अगर
Yes.
सारे एंगल से सीधे हुए तो फिर हमें एच की वैल्यू 0 ही होगी.
Yes, definitely. Correct.
Okay.
So whenever there is a inclined forces are given, there will be HA. Whenever there is a only vertical loads are there, so HA will become directly 0. Okay, it means you have understood now. Are you getting
Yes.
all of you?
Yes, sir.
Okay, take down all of you. Take down. ये थोड़ा different है ना problem, आज का problem. Is it
Yes, sir.
interesting? Interesting है ना?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
सर एग्जाम्स में डायरेक्ट कैलकुलेशन नहीं क्या चलेंगे सर?
Yes, directly. You have to draw
मतलब वो
the
फॉर्मूला बिना लिखे.
नहीं फिगर ड्रा करने का, you have to draw the reactions, again you have to start the calculation.
Okay, sir.
Roll number 4 absent. Roll number 6
Sir,
हाँ
the last calculation आहे का correct?
हाँ 99.64.
82 is sir.
नहीं
No.
चेक करो
No, sir.
हाँ 99 करेक्ट है ना आंसर?
Yes,
Correct है sir.
करेक्ट है, और एक बार चेक कर दे. इट इज आंसर इज करेक्ट. चेक करो. 16 roll number 18 19 22 31 43 44 51 64 51. Are you present or no? Alim Sayyed. 51. I will consider you as absent. 51. You have to give response. Either to number hai, but whenever I am calling, you are not giving responses. I will treat you as absent here. Okay, absent numbers 4, 6, 16, 18, 19, 22, 31, 43, 44, 51, 64. All these numbers are absent numbers.
Sir, 43 present.
43 present. Yes, like this you have to give me response. Otherwise, I will consider it as absent. Okay. Any other numbers?
सर
हाँ
वो आप प्रेजेंट के बाद बताता हूँ सर.
एक मिनट. absent numbers और एक बार बता रहा. 4, 6, 16, 18, 19, 22, 31, 44, 51, 64. Okay, these are absent numbers. Okay.
Sir,
हाँ.
82 से थे sir. 82.
82
हाँ
आ
सर
रहा है क्या?
82 ही आएगा सर.
82.
यहाँ पे भी देखो ना सर. हाँ
एक मिनट
10
एक मिनट
82.32.
3 मिनट.
सिर्फ लास्ट कैलकुलेशन गलत है सर.
No, sir. सही आ रहा है.
20 into 20.
82.32 से थे
Is
sir.
correct.
2 रह गए.
Check it. I have also
नहीं कैसे गलत?
19.
सर वहाँ पर 2 रह गया है. 20 into √3/2 into 2.
हाँ इधर देखो चेक करो और एक बार 20 into √3 divided by 2 plus 45.
into 2 रह गया है सर.
सर 45 के बाद ही वो आ रहा है सर. वहाँ पे कुछ तो मिसिंग है, नहीं तो आपका 99 नहीं आएगा, 82 ही आएगा.
82 ही थे
एक मिनट.
sir.
सर हमें 7.5 को डबल करना होगा तब जाके वो आएगा.
एक मिनट I will check it. I will calculate.
20 into √3/2 into 2.
सर आपने वहाँ उसकी लेंथ.
Yes. I have made a mistake. Yes, correct. अभी देखो आप 20 is correct. 20 into 1 is 20 I have written. Okay, I have written here. See where I have made a mistake. So 20 into sin 60 is 20 into sin 60 root 3 by 2. Again multiply by 2 है इधर. Okay, इधर multiply by 2. So this
Yes,
2 this 2 get cancelled. Now अभी calculate कर दीजिए सभी लोग.
Yes,
20 plus 20 into root 3 plus 45. Are you getting same answer?
Yes, sir.
99.6.
So इधर से कैलकुलेट किया तो आपको करेक्ट आंसर मिलता था. ओके, इधर मैंने 2 आई हैव मिस्ड. ओके, देन गुड. ओके, इज दिस आंसर करेक्ट है ना 99.64?
Yes, sir.
Yes, sir.
ओके, कैन आई गिव वन मोर प्रॉब्लम होमवर्क?
Yes, sir.
Yes, sir.
Yes, sir.
So all of you try this problem.
पप्पा पंढरपूरला चाललाय काय?
Yes, please mute yourself. So take this beam problem.
कशाला?
Yes, roll number 2 Mega Jawan, please mute yourself. Okay, so take this figure. So it is 45 kilonewton per meter. 45 kilonewton per meter. Okay. This is its point A. This is its point B. This is 2 meter. This is 0.5 meter. Okay. So there is a load acting at this point. That is 68 kilometer. I will give one more problem.
सर वो 45 है ना?
45 unit. Yes, take down this. Okay, so this is a problem for homework. Okay,
Question, sir.
so find the support reactions. Find the support reactions.
सर 0.5 क्या है?
0.5 is distance.
Distance.
Okay, distance from A, that is from the support to the till its the loading distance. This distance. So you try these two problems. Okay. So remaining we'll see in the next class. Is it clear, everyone? Okay, take it in the screenshot.
Yes,
We'll
sir.
stop now.
सर कल के होमवर्क का
आंसर मैंने डिस्कस किया ना, स्टार्टिंग आपने ज्वाइन लेट हो गए क्या? स्टार्टिंग ही डिस्कस किया मैंने. Okay,
Yes,
ये
sir.
वीडियो अपलोड करते हैं. If you want you can check it. Okay, ये वीडियो में. Okay, we'll stop now. We'll continue in the next lecture. Okay, thank you all. Have you taken this screenshot? Problem?
Yes.
Yes, sir.
Okay, we'll stop now. We'll continue in the next class. Okay, thank you all. Okay, bye.
बाय सर.
Good night, sir.